Question 16 says a block of mass m moving on a frictionless surface at speed v compresses a spring through a distance x before its speed is halved. The spring constant of the spring is. The student, we can use the conservation of energy, that the change in kinetic energy will be equal to the change in potential energy of the spring. So half mv square minus v square by 4 as the speed becomes v by 2 will be equal to half kx square, which means that 3 by 4 mv square is equal to kx square, or k is equal to 3 mv square by 4 x square. And hence, as we see the given option, the correct answer should be option number 1. Moving on to the question number 17. Question 17 says a body of mass 4 kg moving along a straight line under the action of a force. If kinetic energy varies with time as k is equal to 8t. So k is equal to 8t, then the force acting on the body increases with time, decreases with time, constant or zero. The student, force is equal to ma and the kinetic energy is equal to half mv square. Let us accept these two relations. So this is equal to 8t. From this, if we differentiate, we get half into mass into 2v into dv by dt is equal to 8, or m into dv by dt is equal to 8 by v, and this can be written as 8 divided by under root of 16t by 4. Now this will be equal to 4 by root t, and hence, just student, we can see that as the time passes, this is the force will decrease, and hence for this question the correct answer is option number 2. Moving on to the question number 18. In question 18, an object of mass 4 kg moving along the x-axis so that its position x varies with time as, so it is given that x square is equal to 16t cube. The work done as a function of time has to be calculated. So the mass is also given. The mass is given to be equal to 4 kg. From this expression, x will be equal to 4t to the power 3 by 2. If we differentiate this x, this will be equal to 4 into 3 by 2 t to the power half, that is 6 root t. This will be, dear student, equal to velocity. The work done will be equal to change in kinetic energy, that is half, into mass, that is 4, into v square. So that will be equal to 72 t, and hence we can see that work is proportional to t, and it will be a straight line graph, meaning that the correct answer for this question is option number 3. Now let us solve the question number 19. Question 19 says a stone of mass m is thrown from Earth's surface at an angle theta to the horizontal with the speed v0. Ignoring the air drag, the power developed by the force of gravity t second after the beginning of motion is. The student, at t second the velocity can be written as the horizontal velocity v0 cos theta I cap as it remains constant, plus vertical velocity v0 sin theta minus gt j cap. The power will be equal to f dot v, that is mg in minus j cap dot v0 cos theta I cap plus v0 sin theta minus gt j cap. This will be equal to mg into gt minus v0 sin theta. Student, this is our final answer, and as per the given options, the correct answer should be option number 1. Now let us move to the question number 20. In question 20, a man weighing 60 kg lifts a body of mass 15 kg to the top of a 10-meter high building in 2 minutes. The efficiency of the man is something that we have to calculate. The efficiency will be equal to useful work divided by total work into 100. Now the useful work here will be equal to, that is 15 into g into height, that is 10, divided by the total work, and the total work will be equal to the total mass 60 plus 15 into g into 10. On solving this, we get a value of 20%, and hence the efficiency of the man is 20%, meaning that the correct answer is option number 2. Moving on to the question number 21.